Hey everyone, this is the 2018 Physics AS Unit 1 paper. 7 questions out of 80. Usual 7 topics obviously. Here's the grade boundaries in case you want to see how you would have done. They don't deviate too far from this, but it does change a bit of course every year. Question 1 is the moments question. Bit of bookwork to start. Stating in words the equation used to calculate the moment. And you need that word perpendicular in there, okay? Moment about a point is the force times the perpendicular distance from that point. You've got to have that word in there. Then on to the actual question. They do like to make things very complicated, so they can't just put a nice plank of wood on a pivot point and add some weights. In physics, like they do in maths, this year is about a window, an old school window. This is the handle with holes in it, so you can adjust how far the window is open, right? It says show that, so we like a show that, we have the answer given to us. Show that the clockwise moment produced by the weight of the window is approximately 8 Newton meters, okay? So the only indication we have of any weight is this here, there's 52 newtons, and as you can see it's coming from the middle of the window there, so that's the weight of the window. The perpendicular distance from there to the pivot point is given as 0.15, and of course that's trying to swing in a clockwise direction, so it is these two numbers that I will find the product of, and it comes out as 7.8 Newton meters, which is pretty close to the show that of 8 that they wanted. Next one is a hence, which means use that answer, and even if you didn't get that answer, use the 8 they've given you. Hence, calculate the force that the metal bar will exert on the window. And that's shown there with this little arrow here. And of course what they're getting at there is this system is in equilibrium, so the clockwise moment equals the anti-clockwise moment. And it's that force that's producing the anti-clockwise moment here, trying to spin the other way around the hinge, and the perpendicular distance from there to the pivot point is 0.58 meters. So that force times the 0.58 meters will give you the same answer as the moment in this one, because it's in equilibrium. So I've carried through the 7.8 and bring the times by 0.58 over as a divide, and the force is 13.4 newtons, right? Nothing too tricky there. And then for the final 4 marks on moments, I have 2 people discussing how the force in the metal bar will change depending on what hole it sits in, and therefore the amount that the window is open and this perpendicular distance here to the weight of the window. Tom thinks the force in the bar is greater here. Bethan believes the force is greater in the bar here. Discusser is correct. Okay, now obviously the weight of the window doesn't change. Bethan is correct because of the perpendicular distance from the pivot to the weight of the window is greater in this position here, right? This perpendicular distance doesn't change. It's from the weight of the window to the pivot point that can change. The greater the distance, the greater the moment, and then obviously the greater the force on the metal bar. Okay, so Bethan is correct due to the perpendicular distance from the pivot being greater in position 1. Easy peasy, see you at the next one.